Hey YouTube, I know you guys were wondering about electromagnetic pulse and how to protect your equipment from it. Okay, first off you got to know what an EMP is. And part of it is electrical, as in mass electron discharge. And the other part of it is a magnetic field pulse. To create electricity, you've got to have a rotating or a pulsating magnetic field. Okay, but there's really not a way of protecting against that without some real fancy stuff. So the thing we want to concentrate on is the electron discharge. Well, as I said yesterday, the solar panels are one big solid state device. They are very susceptible, and one of the major electron discharges would be a nuclear explosion. But there are other ways to cause a mass electron discharge. In the comments, or not comments, but description below, I will have a link to a gentleman's video that does a very good job of explaining it and how to protect it. Now, I said yesterday there were people that were erroneously giving out erroneous information about using one of the family service or a pair of family service radios to check if something is EMP proof. Well, the problem is these are FM, frequency modulated. Okay, frequency modulated frequencies act different than amplitude. And what we're dealing with electron discharge is an amplitude spike. With a nuclear explosion, it lasts approximately, understand this is approximately 15 nanoseconds. I mean, a lightning strike will last approximately 1/2 second. So this thing is minuscule time. And the gentleman will, with the link down here, will tell you how to protect a system. Well, he'll give you ideas on how to protect a system that's already up. If the system is not up and it's portable, he recommends wrapping them in 2 layers of heavy aluminum foil and burying them in 3 feet in the ground. Okay, this is great. But I would say wrap them in foil and put them in a trash can, a steel trash can. And the way you got to do that is basically take an AM radio, tune it to a strong station, put it in the trash can, and put the lid on. If it stops working, you've got protection. Again, this is where I was saying, erroneous information, because you're talking apples and kumquats when you're talking AM and FM. They act differently. Okay? What all would be destroyed? Anything with a microchip. USB drives that you've got all kinds of stuff stored on, they're toast. Your handy dandy calculator, toast. It's got integrated circuits in it. A lot of the integrated circuits here are working at less than 1 volt. So it doesn't take much of an electron pulse to take out the circuits in it. And likely all your LEDs, lights and stuff would also be toast. Well, that's the way it is, Now, I had a couple people wondering how I made up that little panel, like this, that I put on Jack's charging solar station. Well, what this is a double plug from West Marine. And the nice thing is they're sealed, but this has got 2 of them. Now you're going, well, where'd you come up with that double USB port? Okay, very simple. There's two companies that I know have them. One is Blue Sea Systems, and the other one is Sea Dog Line. And basically there it is. And again, it's just a double USB port. If you put this in a system, you want to have a switch-in line so you can turn it off, because this has circuitry in it that's drawing power all the time. So you want to be able to turn it off, you know, basically a master switch. Okay, something else I was going to talk about is the hack for these LED lights. What I use is, again, this little guy. That is a switching regulator. Yeah, there's my thumb, there's it. It is a little bitty thing. Okay, they come in a variety of voltages. This one happens to be set for 3.3 volts. Most of the white LEDs like 3.7 to get maximum brightness, but running 3.3 you lose about 10-15% on the light output, but the draw on them drops by over half, which is very good. The other thing I talked about is a lot of these little bitty cameras here. They use 3 AAAs. Okay, one of the things I'm going to do is show you how to set it up to use either 4 pen lights or 3 pen lights, or if you really want some record time, 3 D cells, or not D, C cells, excuse me. But you can also use C cells. Okay, through Pololu, which basically does robotics, they have step-up voltage regulators. So you can take 3 volts and step it up to, with the adjustable one, you got to adjust it. You got to adjust the volt. You can adjust the voltage from what, 2.5 to 8, I believe it is. So, which is really kind of nice, because you can take 3 volts from 2 D or C cells and step it up to run your camera, which is wonderful, because you can quite literally take the batteries down to dead, as in they will work at voltages down to 1.5 volt. Depends on which one. Some of them want 2. Okay, the interesting thing, you know, right now we've got an overcast day. It's, you know, kind of what we kind of typically see here in the Northwest. Right now I've got it hooked up and we're showing 19 volts. Okay, this is great. This is wonderful. We have 19 volts, which one gentleman did a study with using, you know, prime numbers and solar cells, and he was recording the voltage. Well, that's fine. He's had the voltage, but now let's check what kind of amperage we're getting. And we're getting basically 0.08 amps. You know, not even a tenth of an amp charge on a day like today. And this is with a 20 watt, a panel that is rated 20 watts. Under full sun, I'm getting almost 1.2 amps out of the same panel. So when they say high efficiency panels, it's kind of a nebulous thing, because they rely heavily on sunlight. So we'll get into that and a few other odds and ends. And that's also